dot products. So dot products is not too bad. It's just basically some kind of multiplication and addition going on because multiplication and addition are the same thing. So they also call it like scalar product or inner product, and that basically is just saying, well, you're multiplying like information. So the first term is multiplied with the first term, the second term was multiplied with the second term. So if you look right here, it says if v equals a sub 1 and b sub 1, and w is a sub 2 and b sub 2, then the dot product v dot product of w, it's supposed to be like a bigger dot, it's weird, is defined as what I have written below. So it's really not that bad. So if we want to dive right into number 1, define the dot product, you're just going to multiply the inner and the outer terms. So you're going to do 5 times 1, which is 5, and negative 2 times negative 8, or negative 9, which is positive 18. And that is the dot product. Oops, sorry. No, it's not. I lied. What am I doing? Okay. You're doing 5 times 1. I don't know what I'm doing. Sorry. I do. I'm very scatterbrained today. And then negative 2 times negative 9. So you're going to get the 5. You're going to get the 18. And you're going to add those two together and you get 23. So the dot product is a numerical answer. Why I try to write it in vector form is just beside me. So it's a numerical answer. Okay. Now, if you look at C and D, it's set up a little bit differently. But you're doing the exact same thing. So multiply the same thing and the same thing, or same terms, and then add them together. So we're going to take 3 and negative 2, and you're going to add that with negative 7 times negative 2. That kind of blends in. So that gets you negative 6 plus 14. Ooh, sorry, I clicked something and then I messed up my writing. Negative 6 plus 14, and that gives you 8. Okay? So if you notice, it's a numerical answer, so really not that bad. Okay. Now, orthogonal is like the big kid way of saying perpendicular. So orthogonal is just saying it's perpendicular. So that's like, this is the big kid way of saying it. The big kid way of saying perpendicular is orthogonal. Better explain. So if the vectors are perpendicular or orthogonal, then their dot product is going to be equal to 0. So right here, vectors with a dot product of 0 are also described as orthogonal. So orthogonal and perpendicular are the same thing. So let's go ahead and do 3 and 4. We'll fill out this table in the next video, and then do the rest of the stuff in the next video. So you're doing the exact same thing. You're just finding the dot product, but you're saying if it equals 0, it's orthogonal. So we're going to do 3 times negative 28 and 7 times 12. 3 times negative 28 is negative 84, and 7 and 12 get you 84. So these are orthogonal. So I'm just going to write therefore, remember that means therefore, orthogonal. And that's an N that looks like an H. My handwriting is just horrible. Okay. Next problem, same thing, kind of set up just like number 2. You're going to find the dot product of x and y. So you're going to do negative 5 times negative 1. And then you're going to add negative 1 and negative 5 multiplied together. So it's going to be 5 plus 5, which is 10. So therefore, not orthogonal. So not too bad. Just a little bit of simple math. All right, so I'm going to end this video. I'm going to pick up the next one with doing the property. So in the upper left-hand corner, you should see a link right to that. All right, see you in the next video.